Hi there, welcome back to another exciting tutorial of Biochemistry Learning Lab.
Today, we are gonna learn how to draw the structure of any amino acid in less than 5 seconds.
Let's get started.
So, let's begin with the aliphatic amino acids.
Aliphatic amino acids are nonpolar. So, what is an aliphatic amino acid? It refers to hydrocarbons that lack benzene.
You mean that it can be cyclic, but there is no benzene group?
Exactly.
As you know, here is the constant part of each amino acid, and this is the side chain. The lysine is the simplest amino acid and the only non-chiral.
Wait a moment. What is a chiral carbon?
A chiral carbon is attached to 4 different groups. Glycine is connected to 2 hydrogens, so it's non-chiral.
Alright. Alanine is ALA, first letter A, has a metal group instead of hydrogen. From here on in, all the upcoming amino acids will begin with alanine. Turn CH3 to CH2 or CH for additional groups, but they all start with this line.
So Sabir, is this a chiral carbon?
Yeah, it is, because it has attached to 4 different groups.
Bravo. In order to draw valine, we start from alanine. Valine has an isopropyl group, which is an upside down V. Just like this. It is an aliphatic and it has nonpolar side chain.
Here, alright. Rolling is the only ring structure, but note that it's not aromatic. Just notice how it swings back around. Like the letter P. This helps me to remember 3 letters pro and their abbreviation P, which swings back around just like the letter P. NH3 positive here turns to NH2 positive.
Okay.
In order to be connected to this structure.
Pay attention please. Don't just watch the video. Pause the video. Draw it again and again until you have it. Shake a leg please. Regarding leucine, it again starts with alanine. I should mention that the word leucine starts from L. So, draw it in a way the L is read from both sides. Focus.
L. S. L.
So
You are.
isoleucine is the conformational isomer of leucine. We take an I for isomer and Le for leucine. So to start with alanine, add an I. This is I. And add an L here. Isoleucine. I can do it in my sleep. Finished. Now, let's discuss the sulfur-containing amino acids.
Methionine, abbreviated 3 letters, MET,
Okay.
is drawn as an elongated M and add sulfur atom here. So we draw the M and we add sulfur atom instead of carbon in the 3rd place.
Pay attention to the letters of cysteine. 2 letters C and S are bolded here. So, come here. Just draw carbon
Okay.
and add sulfur here. Carbon, sulfur, C and S, cysteine. Easy peasy.
Alcoholic amino acids Everyone knows that alcohol is a serious threat.
I get it. That's the key point. You mean that ser refers to serine, T stands for threonine,
Alright.
and tyrosine. So let's begin with serine.
As usual, we start with alanine.
Okay?
Now take a deep breath.
Okay.
We just add an OH here.
Really? Just that?
Yes.
Are you serious?
Oh, yes, sir.
What's that?
Oh, sir is a key point to remember serine.
Wow. Now let's move on to threonine. I prefer to read it threonine, 3-OH-nin. That's 3 parts. Draw the constant part. Alanine, the first part. Add a hydroxyl group and a metal group.
Only 3 parts. Methyl group, carbon, and OH.
Right. In the case of tyrosine, what?
Don't tell me you wanna relate it back to tire again.
Good guess. You got it right. Read it tyrosine. Tyrosine. Start with alanine
A benzene group as a tire?
and OH on it. Tyrosine.
Great.
Acidic amino acids. There are 2 rules in order to draw acidic amino acids.
First rule,
Whenever faced with an acid, add a carboxyl group to the end of the R chain.
for instance, for aspartate, abbreviated ASP.
So draw the constant part.
Here is it. NH2,
Okay.
H2, carbon, carboxyl group.
Hydrogen.
We continue with alanine.
And add a carboxyl group to the end of the R chain.
For second rule, to draw the glutamate, we just need to add 1 carbon to aspartate.
Let me show you. So, raise the carboxyl here. Add 1 more extra carbon. And carboxyl group. Here it is.
Since in the English alphabet, G comes after A. Because of that, glutamate has 1 more carbon than aspartate.
Glutamate, G. It's a giant form of aspartate. Bigger and giant form. It's jealous and he always wants an extra carbon. Amide amino acids. There are 2 laws in order to draw amide amino acids. First law, whenever faced with an amide, add the amide group carbon, double bond, oxygen and nitrogen to the end of the R chain.
For example, in terms of asparagine, abbreviated ASN. You start from alanine, draw the constant part, and H2 attached to carbon, hydrogen atom, carboxyl. Start with alanine.
Okay.
Because it ends with N, notice it ends with amide group. Focus. Amide group. This N represents the nitrogen atom here. Second law.
In order to draw glutamine, add 1 more carbon to asparagine. So draw the constant part.
Okay. We start
Start with-
from alanine,
Add 1 more extra
Carbon.
carbon. And the amide group at the end of the R chain. This nitrogen, this N, represent the nitrogen atom here.
here.
Now, let's have a brief review.
I'm aspartate as an acid. You can call me by my nickname, AS. I'm always thankful. I start with alanine ending with carboxyl group.
And I'm glutamate. As an acid, just call me glue. I'm bigger and more giant. I'm jealous. I always want an extra carbon here.
I'm asparagine. You can call ASN. I'm always thankful. One carbon and amide are enough for me.
And I'm glutamine. As an amide, just call me GLN. One carbon isn't enough for me. I need one more extra carbon before the amide group.
Aromatic amino acids, they all contain benzene. This is called benzene.
If you add a methyl on benzene, it will convert to phenyl. In terms of phenylalanine, pay attention please. Read it. Phenylalanine. Phenylalanine. Okay, we have the alanine and add phenyl on it.
Well, we have already studied tyrosine. It's tyrosine. So starting with alanine, draw a tire. And add an OH on it. Hydroxyl group.
Once upon a time, there were 3 regions in tryptophan CD.
Disadvantaged area or low-income region.
One carbon lives in this area.
An average income community.
Include 5 members ring with nitrogen in the floor.
An upscale neighborhood, a rich group that drives a Benz. I mean, a benzene.
The last group is basic amino acids. If you put them in solution, the pH will be more than 7.
There are 2 key points to remember the structure of basic amino acids.
Firstly, they all contain amino group.
Secondly, because the word base has 4 letters, so they all contain 4 carbon in their side chains.
Lysine is the first basic amino acid. It looks like line. We draw the constant part.
Alright.
We add 4 carbons in a line. 4 carbons. And after that, we add amino group at the end.
Great. Histidine is our second basic amino acid. It looks like a house.
Yeah.
Draw the constant part. Start with alanine.
Okay.
And add a house. It's a house.
Yeah.
With 2 nitrogens. 1 nitrogen in the floor and another in the side. And 1 double bond for each nitrogen. Look, pay attention, it looks like a house. And arginine.
Arginine has 3 arms.
Arginine. 3 nitrogen arms.
Draw the constant part. After that, 1 carbon attached to 3 nitrogen.
So, Armin, 1 carbon is here.
Yeah.
How many left?
3 carbons.
There it is.
1, 2, 3.
Each carbon has 3 valences, has 4 valences, one of which is attached to this nitrogen, another to this one. 2 remains that form a double bond with the last nitrogen. Now we have reached the end. I hope you enjoyed it.
Don't forget like and subscribe for more videos.
Feel free for any comments.
Ta-ta.